So we're going to have a theorem that is going to apply to this scale change notes that we've taken. And the theorem says that y equals b times the sine of x divided by a, with the scale change then a times x and b times y, that the amplitude is equal to the absolute value of b, which we had talked about. It's got to be the absolute value of the scale change on the b, and the period is equal to 2 pi times a. Right? This applies as well for the cosine. If y equals b times the cosine of x over a, excuse me, the scale change is ax by. The amplitude is the absolute value of b, and the period is 2 pi times a. And remember that frequency is always the reciprocal of the period. Okay? All right, so given an equation, the first thing I'm going to do is write my scale change. And my scale change would be 2 times x, because in the equation, x is divided by 2, and 3 times y. The amplitude is always right here, and whether it's positive or negative, that's going to be my amplitude. It's the absolute value of that, and so it's 3. And I can even just look at my scale change on the y and take the absolute value of that. Period is always 2 pi times the scale change on the x, which is 4 pi. So let's just make a note. Amplitude is the absolute value of the y scale change, and period is always 2 pi times the x scale change, which makes sense that the y scale change affects how high and low the graph goes, and the x scale change affects it left to right, which is the period. And frequency is simply the reciprocal of the period, 1 divided by 4 pi. All right, number 2. Given the equation y equals 1/4 times the cosine of x divided by 5, write the scale change. 5 times x, because in the equation it says x divided by 5, and 1/4 y, or y divided by 4. So my amplitude is simply going to be 1/4. So maybe I wanted to write this instead of y divided by 4 for answering these questions. Maybe I'd rather write it as 1/4 y, like that. The period is 2 pi times 5, or 10 pi. The frequency is the reciprocal, 1 divided by 10 pi. I do want to note, this is not 1/4 pi. That would mean pi was in the numerator. This is 1 divided by 4 pi. This is not 1/10 pi, because that would mean pi was in the numerator. It's 1 divided by 10 pi. Right, example 4, sound waves. A tuning fork vibrates with a frequency of 440 cycles per second. The intensity of the tone is the result of the vibration, whose maximum pressure is 15. And then it gives us the unit. Find an equation for the sound wave produced by the tuning fork. All right, a couple things we need to know. The tuning fork vibrates with a frequency. That's going to be important. And then we have a maximum pressure. It's important that we understand that pressure is equivalent to amplitude. All right? And so if our amplitude is 15, that means that our scale change on the y must be 15. We don't know what it is on the x, but we know it should be 15y. It's nice to have the scale change when we're going to write our equation. And we know that the frequency is 440 cycles per second. Remember that frequency is equal to 1 over, or the reciprocal of the period. So 1 over the period. And the period is 1 over 2 pi times a. We don't know what a is, but we can find out because we know that the frequency is 440. Now, in an instance like this, when I have two fractions that equal each other, I simply cross multiply and I get that 880 pi a equals 1. So to solve for a, I divide both sides by 880 pi, and that's what a is. So if that is my a value, that means it's 1 over 880 pi. When I go to write my actual equation, and for sound waves, we're going to go ahead and use sine. It's y equals 15 times the sine. Since I'm dividing by 880 pi in the rule, I'm going to multiply by 880 pi times x. So pressure is amplitude, and because frequency is 1 divided by the period, or 1 divided by 2 pi times a, we could solve for a, gives us the scale change, which then allows us to write our equation. All right, let's go to example 5. Find equations from the graph. So it says that below is the image of the y equals the sine of x under a scale change. Find the equation. Well, we need to figure out what the scale change is. So first thing I'm going to do is, well, when we're trying to figure out equations, okay, whenever you're asked to find an equation, your first step is to determine if it's sine, cosine, negative sine, or negative cosine. I'm saying this step because this will, on a graph, be your first step. I won't always just tell you, hey, this is the image of sine. So I look here, and it goes up and comes back down. This is a normal sine curve. If it was a cosine curve, it would start up here and make a U shape. So I know that it's sine. That's my first step. My second step is to figure out the amplitude. And I look, it goes 4 up and 4 down, so it's 4. The other thing that I want to know is what is the period? And it does a full sine curve, and it only has to go to pi. My third step is to find the a value. So I know that 2 pi times a is equal to pi. So a must have been 1/2. And remember that x lies in the equation. So maybe my fourth step should be to write the scale change. 4, oh, not 4, that's for the y. I meant to write 4y and 1/2 x. And my fifth step then is to write the equation. Y equals 4 times the sine of 2x. Right, I'm going to follow my steps here. My first step is to determine my equation. It says cosine, but actually it's an upside down U, so this must be a negative cosine equation. My second step is to determine my amplitude, up 3 and down 3. Now, what I do is, so that I don't forget that it's a negative cosine, my amplitude, therefore, is going to be 3. That makes my B value negative 3. B is what is on the scale change for the Y. Okay? So because the amplitude is 3, my B value is negative 3 because this is negative cosine. My third step, oh, actually I've got to write down my period. Sorry, forgot about that. My period is a full curve takes 2 pi over 3. So my third step is to figure out that A value, 2 pi times A equals 2 pi over 3. I'm solving for A, so I'm going to multiply both sides by 1 over 2 pi. We cancel here, and I get that A equals, these cancel, 1/3. So now my fourth step, my scale change, is 3x because, oh, no, it's not. I'm thinking the equation. I'm jumping ahead. 1/3 x. This is exactly what it is. And this is my B value, negative 3y. Therefore, in my equation, I have negative 3 cosine of 3x. Y equals, sorry. Okay, let's go to our next page.